Hello calculus students and seekers of general truths. In this video, we will learn the derivative of the sine function, and then I will leave it to you to figure out the derivative of the cosine function. Now, we are not going to do a rigorous proof here. The rigorous proof is wonderful, but it's quite messy. Here, I want to illustrate the concept and help to show you why this is true or make some sense of this, even if we don't necessarily prove it in all of its glorious details. So we're going to use a graphical approach to this. Okay? In calculus, we want to be able to do everything in 4 different ways: with symbols, that's algebraically; graphically, with images; numerically, with numbers; and in words. Okay, so here we're going to use kind of what I call, again, the graphical approach. We're just going to look at a picture of the graph here, and from there deduce what the derivative is. So first, one thing you do have to know is what is the sine function, or what is the graph of the sine function. Okay, so if you've forgotten, it's a fine time to review. I'm going to draw it here so I can show you and explain. Okay, so the sine function roughly looks like that. It is a sinusoid, right? It's basically a wave that continues on and on and on and on. All right, and I've kind of fixed the picture here a little bit just so that we get a more complete picture of the sine function. And now we're going to figure out what the derivative is by using a graph. So I have the f function graph right here, and now we're gonna figure out what does the derivative graph look like. So always start with extremas. So we know that since the slope of f is 0 at the extremas, that means the y value of f must be 0 there. In other words, the y value of f prime. In other words, f prime has x-intercepts wherever f has extremas. So there's a 0 here, a 0 here, a 0 here, yet another 0 here, right, and another 0 here. These specific points, for those of you who are familiar and remember your unit circle, this is pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, all the odd multiples of pi over 2. And so let's just start by drawing what the function looks like. Well, if you look at f, this f has a positive slope between this dot, this is negative pi over 2, and positive pi over 2. Okay? So between negative pi over 2 and positive pi over 2, f has a positive slope. That means f prime must have positive values. So it must go from 0 here, it must all be positive, and then return to 0 over here. Now between pi over 2 and 3 pi over 2, the slope of f is negative, or f is decreasing, so that means the values of f prime must be negative. So we're drawing a graph that is negative between those points, and they come up and meet back here at 0. And we can repeat this again, right? Between 3 pi over 2 and 5 pi over 2, we also have a similar scenario. This goes up and goes down because the slope of f is positive, so the y values of f prime must also be positive, and this continues. And now you can hopefully see what this pattern is. Okay. And if you look at the red graph, well, what does that look like? What is f prime of x? Well, it's none other than the cosine function, right? If you look at that is in fact the red graph right here is in fact the cosine function, is identical to it. So we know definitively now that the derivative of the sine function is the cosine function. Okay? And again, this is not a rigorous proof. If we were doing some sort of theoretical work and we want to know for sure, we would have to do this using the limit process. But at this point, we're trying to just develop the understanding of this from the graphical standpoint. And I will give this a solution eventually, but I leave it to you now to figure out what is the derivative of the cosine function. Follow the same graphical method. You may be tempted to just Google this, and you certainly can. There's nothing that really stop you, but it will be so much more satisfying and so much better for your understanding if you can in fact, and when you in fact, figure out this derivative for yourself. And then once you figure it out, then you can go and perform an internet search and figure out and see if you are correct. As always, keep working hard. Always move a little bit closer to the answer and the truth. Thank you for watching and have a wonderful day.